Bismillahirrahmanirrahim and Assalamu alaikum. How are you, dear students? I am your chemistry teacher Faisal Omar, and today we are going to study about the states of matter. First of all, we know that which one? Yes, we are going to study about the solids in this lesson. Okay, so let's study the solids. Solids are one of the common three states of matter, or sometimes we can call one of the four states of matter, because plasma is also included in the states of matter. So in the solid we will have a definite shape and definite volume. Okay, the particles that form solids are bonded together with a great force. So normally they won't change their places until a force is applied upon them. You can see over here the solid particles making a solid substance. All of them are solid particles. They could be molecules or atoms that form a solid state of a substance. Let's see some properties of the solids. Solids will have a definite shape. For example, this pen is a solid. It has a definite shape, and it has also a definite volume. Okay, and it will have definite melting point if the solid is made up of only one substance or only one material. If it is a mixture, in this case, it can have several melting points. But if solid is a pure substance, then it will have a definite melting point. Solids will have higher densities than the liquids and gases, and the solids are incompressible. We cannot compress solids normally, and they have low rate of diffusion. They don't diffuse each other. There are two types of solids. The first one is crystalline solid. Second one is amorphous solid. We will study the types of crystalline solid, but we will not study much more about the amorphous solid. We will just introduce the amorphous solid for you. The crystalline solids is clear that they are the crystals. Okay, they are firm and they have a definite geometrical shape. And for example, diamonds, metals, salts, quartz, these materials are the examples of crystalline solids. What about the amorphous one? Amorphous solids are also rigid structures, but they lack geometrical, well-defined shape. They don't have a well-defined geometrical shape when we study their structure. The common examples are glass, gels, plastics like PVC, polyvinyl chloride. These kind of solids are known as amorphous solids. You can see the difference of amorphous solid and crystalline solid over here. This is glass. Glass is an amorphous solid, and this is quartz. Quartz is crystalline solid. You can see the shape of their structure. Okay, they have a specific, unique geometrical shape. They both are made of silicon and oxygen. And when you look at the glass, they don't have unique or defined geometric shape. So you can see every ring is different from the another. That's the difference between amorphous and crystalline solid. Let me tell you again, crystalline solid will have a fixed shape when you study their structure. They have a fixed geometry, and in amorphous solid they won't have a well-defined shape, and their geometry will be not similar like the crystalline solid. So that's the reason that their properties may differ with each other. Okay, students, let's study the types of crystalline solid. How many types of crystals do we recognize? There are four types of crystal. The first one is ionic crystal. The next one is metallic crystal, molecular crystal, and covalent crystal. What is ionic crystal? Ionic crystals are those crystal or those solid which have ionic bond between the atoms of each other. We know that in ionic crystal there will be positive ion and negative ion, or we can say positively charged cation and negatively charged anion. Okay, and generally when we study these ionic crystals, they will mostly form by the reaction of first or second group of the periodic table with the 16th or 17th group, which are non-metals of the periodic table, like halogens. For example, sodium belongs to the first period of the periodic table, so first group of the periodic table, and chlorine belongs to the 17th group of the periodic table. When they react with each other, they form crystalline solid. So we can say that crystalline solids are hard and brittle, and they have high melting points. And mostly crystalline solids can be, sometimes crystalline solids can be dissolved in the water as well, but it depends on the solubility of the solid. And the ionic compounds or the ionic crystals, they do not let electricity to pass from them in solid form, but they can pass electricity in molten form or in a when they make a solution with the water. In this case, they are electricity conductor. You can see a sodium chloride crystal over here. This is a sodium chloride cube, and you can see over here, these are the crystals of the shape of the geometry of the sodium chloride lattice. You can see this is sodium and the green one is chlorine, and they are located alternatively, like negative charge, positive charge, negative charge, something like this. This was the ionic crystal. Let's study the metallic crystal. Metallic crystal, the metals that we recognize mostly they're metallic crystals. Okay, in metallic crystals, we must know that there is a kind of metallic bonding between the atoms of the metal, and there's a sea of mobile valence electron that is present between those atoms of the metal, or those positively charged ion or cations of the metal. Okay, so as a result, the metallic crystals are very good conductors of electricity. Examples are iron, copper, nickel, gold, silver, aluminium, etc. You can see a metallic crystal over here. This is a silver metallic crystal. It's a silver, and you can see over here, these are the positively charged cations of the silver, and electrons are located between them. These electrons are the mobile valence electron of the silver, or we can say delocalized mobile electrons of the silver. Let's go to the next. Next, we are going to study about the covalent crystal. What do you think when we say covalent crystal? You must know that when we call covalent, there must be a covalent bonding between the particles that form covalent crystals. Okay. So in the lattice points of these crystals, there must be a covalently bonded atom. Okay, so we can say that these network covalent crystals are hard and brittle, and they have extremely high melting and high boiling points, and they are composed of atoms rather than ions. We won't see any ion in this covalent network crystal. We will say atoms. Atoms are covalently bonded with the neighboring atoms. The examples are diamond, quartz, and graphite. You can see over here. Here's a diamond. Okay, so one carbon atom is bonded with the other carbon atom. They are forming a tetrahedral geometry with each other. This is the natural diamond, and this is the structure of the diamond. Okay, so each carbon atom is covalently bonded with other carbon atom, and they are forming a tetrahedral structure. That's why they are incompressible, and they are very hard, and they're rigid materials. The last one is molecular crystal. As is obvious from its name, it's made up of molecules. So, for example, let me give you an example, like ice. We remember that intermolecular, there were three kinds of intermolecular forces: London dispersion, dipole, and hydrogen bonding from our previous lessons. So in water, there was hydrogen bonding. So in molecular crystal, these intermolecular forces are bounding the molecules with each other. Okay, for example, when water gets cold and it turns to the ice during the decrease of temperature, the intermolecular force hydrogen gets quite stronger, because now the molecules cannot move freely, because the temperature has decreased. So the vibration of the molecules are less. So that's why they form a structure. They form a crystal. This crystal is a molecular crystal. We can say that ice is a molecular crystal. Okay, so for example, ammonia and glucose, when we see the crystals of glucose, they're also molecular crystal. You can see the example. This is ice crystal, and this is the shape of the crystal of ice, or the structure of the crystal of ice. You can see each one of them is a water molecule which is bonded with another water molecule with the help of hydrogen bonding, and they form a rigid and they form a hard structure. And this is the ice. Okay, students, hope you have learned the types of solids and then the types of the crystals. And still, if you have any question about these topics, you can write in the comment section below. See you next time. Goodbye.